Our next presentation is by Cecil Jones. It is the performance and safety enhancements using new preservation techniques. Mr. Jones is the president of Diversified Engineering Services Incorporated and has over 43 years of experience in construction and materials, including over 30 years with the North Carolina Department of Transportation, where his last position was a state materials engineer at the time of his retirement in 2009. He provides engineering consulting services to clients in the area of research, specification development, quality management, appropriate use of recycled materials, new technology evaluation, and implementation, training, and certification. Please welcome Mr. Cecil Jones.
Thanks. My pleasure to be with you here this morning. I want to talk about a treatment that was done in North Carolina several years ago, utilizing a combination of pavement preservation techniques that was pretty successful. We'll talk about the issues faced, the history of the project, issues faced, project design, what some initial results were. Those were reported at a couple of the regional meetings after a year and a half. And pretty unique here, we actually had 3-year crash data. And so the focus of today will be a report on the 3-year improvements, safety improvements that came from this project. This project was on I-40 near Wilmington, North Carolina. I-40 goes from Raleigh to Wilmington, very busy road, especially on Fridays and Sunday afternoons, people going back and forth to the beach. These sections of I-40 were originally placed in 2001, or in that time frame, and in 2010 and 11, sections were beginning to fail, and they were failing rather dramatically with the open graded friction course. It was just breaking loose and deteriorating very rapidly. Accidents were increasing. This from the fall line in, probably 40 miles of that area, was very flat. And these sections were failing with severe raveling, poor surface friction, increased wet weather accidents. That's what the data we're going to look at. And in this last section towards Wilmington, traffic accidents and not so much the raveling, but the traffic accidents were increasing, particularly wet weather traffic accidents. And if you'll remember, in the 2010 area, funding in every DOT was pretty critical, and it was here, and the department had been milling and filling and replacing the friction course on other sections, but there was just no funding for this, did not have the funds to do it. Pavement was not performing, or this section was beginning to not perform. Its safety elevations were certainly elevating. And their traditional, as I said earlier, their traditional treatments were just not possible. Something needed to be done, and the department was searching for options. We met with the department and talked about, who had the crystal ball to decide when was this going to fail. Can that failure be delayed? I've called it preservation a time or two, but it really wasn't preservation because it was well past the top of the curve. And then what options do exist? And then the department had to struggle with how to fund it. And the one thing that everybody agreed on and everybody knew was something needed to be done, and it needed to be done fairly quickly. At one of these regional pavement preservation conferences at about that same time, Gary Billier and Colin Durrani had booths beside each other and started talking about their individual technologies. Texturing certainly will address a friction issue, but will do nothing to keep those aggregates in place. Rejuvenation can certainly retard and bring life back to a pavement, but it actually decreases friction, at least temporarily. And this was an interstate highway. The posted speed limit was 70 miles an hour, and most people were doing a fair amount higher than that on their way to the beach or trying to get back home after they had been at the beach. So the kind of like that peanut butter chocolate thing commercial from a long time back, combination of these two technologies may solve issues like this. And that's in fact what that led to. A lot of agencies, when I was with the agency, we always talked about performance specification. We really didn't have any. But this project actually did have a performance-based design and specification and expectation. The outflow meter was to be used to measure the effectiveness of the texturing, and somebody has an outflow meter downstairs if you're not familiar with it, but basically you're measuring how rapidly the water dissipates on a pavement from a sealed or at least semi-sealed surface. And in this specification, it was, we didn't get paid unless the average outflow readings after this work was 10 seconds or less per lot. The recovered binder viscosity had to be a 20% improvement 2 weeks after the treatment. And again, performance-based, we either did it or we didn't, and there was no pay factor if we did not make it. It was, if you don't do this, you don't get paid. And then friction testing, there were no limits set. Not many states are going to actually set and publish a minimum friction number, but it was tested and evaluated. Again, the concern with the texturing was, will that texturing, as fragile as that friction course looked, would that texturing break the aggregate bond that existed? Because that's exactly what happened on those sections prior to that. Is as I said earlier, in a very short time, that aggregate bond just broke and the shoulder was filled up with aggregate. And one thing Gary Billiard taught me very early in this business is that texturing will not make a bad aggregate better. So it's good aggregates remain good aggregates no matter what you do to them, and aggregates to polish will probably polish if you have them exposed to traffic. This was the first use of rejuvenation also in North Carolina on an open graded friction course. And we're hoping that the net friction would be positive. And I also had concerns about this was a PG 76, I believe, that was involved in this open graded friction course. Will we be able to improve that? Colin guaranteed me we would. Obviously, he felt very comfortable because it was in the contract that it would. But that was a bit of a concern. Got a movie here. We had some nice sound, but we can't get the sound working here. So this is just a 2-minute overview of how the project went. Again, wanted to increase the life of the pavement. Cores were taken prior to and after. Skid numbers were taken before treatment. Here's the texturing operation. Using a very small shot with a vacuum system that puts the texture on the pavement. The vacuum system comes behind, so there's no residue left on the pavement. Also extracts and reuses the shot. Then this is a magnetic system that comes around and removes any residual shot that may be there. It's used on airports a lot, and steel balls going through an airplane engine is not a good combination, so it's really effective in getting it up. Here's some outflow testing. After the abrasion, again, skid testing was done then, afterwards. Now we're applying the rejuvenator. And then a fog of water followed up behind that. A mist of water, I guess. Then, once again, skid testing after the application of the rejuvenator. And then 2 weeks later, taking cores, running the viscosity to make sure that we did, in fact, meet the performance requirements that existed. The project design was actually in 6 different segments. 4 different sections on the interstate, on I-40. 2 dense graded sections on a secondary road not too far away, because the department wanted to see how this treatment would work on a dense graded section that was in good condition, relatively good conditions. As you'll notice from there, using this approach, the pavement markings are retained because the texturing occurs between the pavement markings, and the rejuvenator doesn't discolor the markings long term. Testing was done by the contracting team with the outflow meter, by the contractor, with the department certainly observing. Viscosity was by an independent laboratory that was approved by the department, and friction testing was also by an independent laboratory, and the DOT had their equipment out and also tested the friction at that same point in time. Here you can see the befores and after. If you'll notice here on the afters, you can see the little dots or texture that was the result of the texturing operation. Initial results immediately after the project, well, 2 or 3 weeks after the project was done initially, outflow improved 39%. Dense graded section, the outflow meter, improved 73%. Viscosity improved 32%. And skid numbers improved in the neighborhood of 30% from section to section. There was some variation there, but in the overall somewhat average was in the range of 30%. A year and a half after that, skid numbers were back to basically their original levels before this work was done. But the interesting thing was accident data as of 2 years later, a little less than 2 years later, or a little less than a year and a half later, there was 14% decrease in total crashes, 72% decrease in wet crashes, which is what raised the department's interest in doing this work anyway, and 16% decrease in lane departure crashes, and a 75% decrease in wet weather lane departure crashes. Remember those numbers because the 3-year data is going to look very similar to that, even though the skid numbers are back at their original low levels. The department really did a good job. There are not many times that you have long-term data before and after a facility is put in place, and so the department had really good weather data for 3 years before and 3 years after. Long story short, all of the 1 day difference in what they measured, 3 inches difference in total precipitation between the 2 3-year comparison periods. That's pretty close. Total wet days of 25 days difference over 3 years. Rainfall, the original was a few days more. Rainfall per event was a little bit higher, but not much, a little bit higher in the after. And so it's a really valid comparison. It's amazing that those numbers are that close after 3 years. Segment 1, which was the longest section, it was a little less than 8 miles, I believe. And total crashes went from 81 to 70, which is a 14% increase. Wet crashes, 26 to 9, which is over a 3-year period before and after, which is a 65% decrease. Lane departures, 46 to 39, 15. Wet departure crashes went from 22 to 4, which is an 81.8% reduction. These numbers are very similar to the numbers on the slide I showed after a year and a half. So even though skid numbers were showing this was back, something's going on here. Something's going on here. Total crashes here, we won't go over every number. The sections 5, these are the dense graded sections. There were not many accidents either before or after, so the percentages are here, but probably not earth-shattering, but I think the percentages in the before and after on the open graded section, those I'm not a statistician, but those are statistically significant. Those are statistically significant. Again, wet crashes, which was a concern, 26-9. Section 2, which was a shorter section, probably, I can't remember if this was a half-mile section or a 1 mile section, but went from 14-1 over 3 years, 6-2, 4-0. So again, that's probably significantly different. The only one we had that showed an increase in change was in section 5B on the dense graded section. It went from 0-1 over a 3-year period, over a 6-year period, actually, none in the first 3. So that one's 100% increase, and so but from 0-1, so I don't know that that's significantly important. Lane departure crashes, similar kinds of numbers. Total lane departure wet crashes, 22-4. 81.8% reduction, 14-1, 6-2. And again, small numbers here, so but pretty impressive, I think, by most any summary. The bottom line, project was a success. Project was, it exceeded my expectation, especially after the last year and a half after the friction numbers went back to where they were. The safety consideration of this, or the safety effectiveness of this, continued. The rate of pavement distress was certainly slowed. Again, the skid numbers reverted back, and I keep saying that, but I think that is pretty important. The wet weather accidents continued to stay lower. They did not go back to where they were when those skid numbers were at the point they were earlier. Pretty impressive. The current status, the agency was really obviously very pleased with this, because something that in 2011, this was actually performed in 2012, we were all afraid every time I would go down that way while they were trying to get the funding in order to do this, is this going to fall apart before we're able to begin to work? And fortunately it did not, but it's currently in the process of being rehabilitated. They told me they had either let contracts or were preparing to let contracts. I haven't been down that way later. This may be underwater right now because of the hurricane, but again, it met the needs that the department had, and the agency was pleased with this extended life. So I think this technology did bear itself out. It is something, again, not a traditional pavement preservation technology or technique, because it was clearly not at the top of the curve. But something like this, I think, was pretty impressive with having that safety data. And the map, similar to a map that was shown in one of the earlier presentations that I did not include in these slides, in some of these areas, they were using stars, blue stars, green stars, and red stars on the before, where all of these accidents were occurring, and seeing very few or none in these areas after that, over that 3-year period. That's the presentation. Any questions or comments? Yes?
Is CDOT doing any more OGSC? What was the problem with to begin with?
Well,
A lot of it as well.
the DOT is continuing to use open graded friction cores. Again, those of you with gray hair like me remember in the 70s a lot was done, and before modified asphalts and fibers and things like that came into play, there were major problems with those. Started back with the modified asphalts and fibers to hold more. It is being used. This area where it was used here, friction cores went back on it in those sections leading up to this section because of the spray that elimination that occurs, visibility in wet weather occurs. But again, this pavement was 10 or 12 years old when it started showing up. It was placed in, they were all placed over a sequence of time in the late 90s and the first year, 2001 or 2 or something like that. And this issue presented itself in 2011. Other questions? If not, thank you. Be glad to talk to you about it in detail if you'd like.